Oh, hi guys. I see Timofey, Lena, and Nikita have connected us. So what about my voice and sound? Is it okay? Is it clear?
It is okay.
Yes.
Oh, perfect. I see Sebastian. Hi, Sebastian.
Hello.
Oh, hi, Bruno. Today, Portugal with us. Great. Hi, Timo. Okay, Tim from Austria is here.
Hi.
Oh, I see Jorge from Ecuador. Hey,
Hello.
hi. Guys, don't forget to turn on your cameras and leave it on, please. This is our morning greetings from different countries. Oh, hi, Afonso from Ecuador
Hi.
too, yeah? Yeah, hi. In Ecuador is early morning in Saturday, but I hope you are ready to be work and hard work.
Sorry,
so
Svet.
Gabriel, Nurlan, Aura, Ramswarup. Oh, India is here.
Hi.
Great, perfect. Hi, Aura. Yeah. Yeah.
Svetlana?
Hi, Gabriel Narvaez. Nurlan from Azerbaijan. Hey, yeah, perfect. Okay, what about other guys? They are
Svetlana?
afraid the camera view, but it's no problem. So I think we can start, but before we start, of course, so you can unmute your microphone and say hello on English or on your native language. In Russian, it will be Lena. How it will be in Russian?
Привет.
Oh, we don't hear you.
Привет.
Lena said привет. Привет. Привет in Russian. Okay, guys, how it will be in Portugal language, for example, how to say hello in Portugal? You can
Olá.
unmute your microphone.
Olá.
It's my permission.
Okay. Olá.
Hola. Great.
Sorry, guys. I my dynamics wasn't work unfortunately. So Bruno, please, can you repeat it again?
Yeah, of course. Olá.
Hola, yeah, okay, hola. Okay, guys, in Spanish language, who will be say hello? Ecuador, what do you think about it?
Hola as well.
Hola.
Good morning.
Good morning. Buenos días.
Buenos dias. Buenos dias. Okay, buenos dias. Thank you. Okay, how it will be in German language? Sebastian, Timo.
Hallo.
Ja, hallo.
Hallo, guten Morgen, no?
Und Servus auch.
Oh,
Yeah,
thank you, Nikita. Thank you, Nikita. Okay, great. So, hello from Indian team. Who is a teammate from India? No one, unfortunately. They disconnected. I think it was technical problem. Okay, if all students is here, we can start. And Timofey, are you ready to start?
Yes, I'm ready.
Okay. I think we can start our classes, but before we will check our homework. Yeah.
Yes.
Yeah, perfect. Okay, and so Lena, Nikita, could you could you tell us about the homework of our students? How do they perform it? Nikita, you here? No? Okay.
Only 5 people prepared homework and sent to us.
Ay, 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 guys. Ay, ay, ay. So if you didn't perform the homework, you can't upgrade your skill, unfortunately. Okay, so Timofey, I give you the word, and also you can check some examples of the homework from our students if you want.
Sure, I want to check students' homework, but it's better for them to show the homework on their own computers. So who thinks they made the best job doing their homework? Or maybe Elena, tell me who was the best in making homework. We will see this person's slide.
I think that David may show us your homework.
David?
Yeah.
Is he here?
I don't know.
You can
No.
you can say about you
Okay.
can ask country.
And I know that Sebastian prepare homework. Maybe you.
Okay. Should I share my screen?
Yes.
Oh, okay. Should I just run it, or should I try to explain it?
And comment your code later.
Okay.
Okay, it measured 69 centimeters in this point. And here, 58, which is 92, close to the truth. And 52, very close to the truth. So I think 3 out of 4 were correct. Yes?
Yeah.
And now you can explain the code. Well, you can skip navigate wait and proceed with. Oh, you made the calculation inside the callback, so the height is 1.5 minus MSG range in def range callback. I see that.
Yeah.
Well, this is one way of doing that, but you just saw that the drone sometimes does not maintain its height, and this is why the calculations were incorrect sometimes. But there is a way to fix this problem. You can get telemetry every time you check the distance and subtract the value from telemetry. So you can get telemetry Z, and I will just show it a little bit later when we finish with checking homework. I will show you how to do this with telemetry, but in every other aspect, I think your homework is a good example of homework. It is working. And how about LED? Show me the function if age less than L if age. Yeah, this is, it seems to be correct. Yes. All right, thank you. We can continue with other homeworks. Yelena, who will be the next?
Yeah. And next, who will show us this homework is Nurlan, maybe you.
Is he here? I don't see him. Maybe we should remind everybody that we have started and so they can connect.
And maybe Raúl or Gabriel.
I can present it, but I think
Yeah.
it's not correct. But at least I tried.
Oh, look at this cat. Okay.
Yeah, this is the wrong cat because he doesn't like when you make a hugs with him.
This is a wrong cat?
Yes, it's wrong cat. All cat like the hugs but
it's a broken cat.
Huh?
A broken cat.
Yeah, it's broken cat. He need to be repaired.
All right. So who is going to share their screen with homework right now?
Gabriel.
Gabriel.
Yeah, I'm opening it.
Gabriel.
Okay.
You see my screen and you?
Yes.
All right. So this is the code. I tried to put some obstacles on gazebo. It appears to be gone. Don't know why. Didn't save. But I wrote the code like this.
So you just go to the point and set the color to predefined color.
Yeah, I changed the height of these cubes. I changed the position and predefined the effect.
Well,
green, yellow, red.
Yeah. Well, this is not what we wanted from your homework, but okay, you kind of cheated a little bit with that.
I didn't understand really at all, but now I know what I was supposed to do.
Yeah. So you need to check the height and with your rangefinder, and based on that height, you need to set the LED color.
All right.
Okay, and is there anybody else who did their homework and didn't show us? Wait a second.
I can show the homework of those people who are not there now.
Yeah, there were a lot of people who were not there. Yelena, so tell me which code to copy and test, and I will run it in my simulation.
you run code homework by?
Let me find it first. Okay, I see it. From David.
Yeah.
Okay, let's check this code. Okay. The drone takes off and hopefully it will go to the first point. So it should be yellow and the height of the object is about 0.5 meters. The height of the object is 0, it says. Well, it is not correct, but let's see what happens next. It is waiting for some time, and The height is 1 meter. Yes, this is correct right now. Yeah, looks like it measured the distance correctly. And it is yellow. And the final final is also correct. And now we can open the code to check what it's like. Okay, let's check this code. I think this one was pretty nice, but still it didn't recognize one of the points. Okay, navigate wait, range callback, and distance equals message range. Well, yes, this code is commented. Okay, def check height, d1, d2 obj. Height equals d1 minus d2. And what is d1 and d2? Yeah, dist one equals dist.
So guys, if you have any question, you can ask Timofey about your homework, and Timofey will give you the common recommendation and some advices of it.
I think in this code is also Why is here blue, green, and yellow? I don't quite understand yet. So if the author was here, it would be better for him to explain what he wanted to do. But I think David wasn't here, so we can proceed with the other. Yeah, we'll proceed with the solution, which I will show you myself. And let's find what it could be. So the last time we created a program, which one? Let's see, the program that measures distance, goes to certain points and prints distance. The problem with that program is that if for some reason the drone was too low, the measurement of the distance would be incorrect, and we need to actually know exactly what the height of the drone is when we measure this distance. So let's create a new program that that will not have this flaw. All right. So callback returns us the distance in real time, and we subscribe to this to the topic range, and we always get the new range. Then we take off and go to the 0 position. Then let's pretend we are going to our first point. The coordinates will be changed, so I will change them later. For now, we only need to make the right calculations. So in this situation, we just print distance, but we want to actually print the height of the object based on the measurement from the rangefinder. So here I would do the following thing. TLM equals get telemetry, frame ID Aruka map, and height equals. So now we have telemetry. Telemetry contains also the z value of the drone. So telem.z is the height of the drone. So what we want to do, we need to take this telem.z and subtract the dist from that. What will it do for us? For example, if the drone is on the 2 meters above the ground and the dist shows us 1.5 meters, then 2 minus 1.5 is 0.5. So the height is actually the number that we are trying to find. Then what we need to do is determine which color to use for our LED, and we can do that by if statement. If height is less than 0.25, set effect but in my code I have no set effect, so I need to add this functionality to the code first to be able to use that. I will go to the article, LED strip. Copy this one and this one. set effect, and the color for heights around 0 is green. So G equals 255. Elif, so if height wasn't less than 0.25 and it was less than it was less than 0.75, I need to set effect to yellow. So I change it to R equals 255 and G equals 255. So if it is more than 0.25 and less than 0.75, the color would be yellow. And in all the other conditions, we can use set effect red. So I've created this little few lines of code, but I would need to copy them several times in each point, which is not really useful. So it's better to create a function out of this and call this function whenever we need to check this distance. And how do we do that? First, let me put this code to the other place where all the functions are. So I will put it above ROSPy subscriber. I select these lines, hold Alt and press up arrow. Okay, this code is now here. Select all the whole code, press Tab, and write def check. Stands for check height. Okay, and telem equals get telemetry. It will work inside the function. Height equals telem z minus dist. Dist is also available in this function. Telem z will be available, of course, and if height is, everything else is also available. So we have created the function that we will just call wherever we need to. So first point, check height. The second point, one, two, three, four, and I need to return to the original position, then land. And let me now change the coordinates to what we had. I have some questions. Okay. Yeah, Raul said that his microphone is not working, but he wanted to share his screen, but that was a long time ago, so I think we can proceed to the next topic. But now let me change the coordinates here so that we can test the program. Let me open the simulation to find out which coordinates to use. I actually need to save this code as a new file. Okay. So coordinates, let's see. This one is 1 and 2, 1x, 2y. This one, three and 1.5. This one is 4 and 0.5. And this one is 4.5 and 3. Let's check. So
Timofey,
yes.
Raul wrote me about he can to enable his microphone, and could you check his code and commented it?
Yeah, I could. Let's do that after this flight.
Mm-hmm. Okay, and after it, we can start our main program, okay?
Sure. In my code, I actually forgot to print the height, so we will only see the height based on the LED change. So this one should be yellow. If it is, yeah, it is yellow, and it worked. This is red, which is correct. Should be yellow. But it turned red. This one wasn't correct for some reason, and maybe it will be easier to understand if we print the distances. So the last point, The last goes yellow, which is also not correct. Okay, I think it has to do with the height drops that occurred, and we can work on that a little bit later. But now let's check the code from who wanted to check their code?
Raul.
Raul.
Yeah, Lena, could you send this code to Timofey?
Yes, let's check this.
Yeah, sure. I sent you.
Yes, I'm downloading this code. Wait, it's not downloading. Let me check it again. Let me give me a second. I will restart the Telegram so I can download it.
Timofey, if you have problem with the code downloaded, we can send you such as a message. Maybe it will
Can
be
you do
better.
that? But you need to. Can you just save it as py and send me another file containing the same code? Or just download it and upload it again directly to the message without.
Yeah, understood. So, Diana, could you make it this one and try to download it because I have the same problem. I don't know why.
Maybe I try launch this code.
You can try.
My simulator.
Yes,
Yeah.
you can do that.
Okay. I share my screen. And now I can and now you see my screen.
Yes. Oh, Elena, you forget to change a little setting.
Yeah.
Do you want to change it now? Into ground control.
Yeah.
Can you open ground control real quick and go to the settings?
Okay.
Just okay. Yes, press the second button with settings, the parameters button on the left. Yes, and scroll down to parameters. And search in the search bar EKF2, EKF2.
Yeah. Okay.
Underscore F
So yeah.
underscore HGT.
HGT.
Нижнее подчеркивание ГТ.
Timofey, could you explain what is this parameter? What is responsible for it?
You just saw that the drone was, when it was hovering over the object, it jumped up. And for us to not have this issue, we need to change it. So, Елена, underscore, нижнее подчеркивание, и HGT. В поиске параметров напиши нижнее подчеркивание HGT. Вот, и выбери сейчас не range sensor, so select barometric pressure and save. Okay, and when you restart the simulator, the code will work correctly.
Okay.
You can close ground control. Just hit OK.
Yeah, thank you, Timothy. My simulator now work correctly.
I think the distances are not really correct, but we can see, and we can look at the code. Yes. Okay, so the flat color. Okay, and let color just uses distance dist, but in this case, dist is just the measurement from rangefinder, which is not the height of the object. So we wanted to measure the height of the object instead of measuring the distance between drone and the object. So here you should have subtract the measurement of the rangefinder from the height, from the altitude of the drone. So if your drone is flying like 2 meters above the ground, then subtract distance of rangefinder from the height of the drone, and this is your height of the object. And let me see. And yeah, in your code, this is not the case, so this is why it's not quite correct. But still, it is flying, which is also an achievement. So good job. Okay, thanks. Thank you, Elena, for sharing this experience with us. Okay, let me check our schedule for today. Okay, the next topic for us will be the how to write data to a file, because sometimes in competitions you need to create a report that contains information about your flight, maybe information about the heights of the objects or their colors and so on, and that's why you need to be able to write it to a file. And this is not a difficult task, it's actually quite easy. So I will show you how to do that. And I will modify the program so that it writes the heights of objects to the file. Let's begin with a simple code. I will create a separate file for that. And in this file, I will create a variable f equals open. And here I will write the name of the file that I want to create. So when you open the file, you actually either open it or create it. Report.txt, and you need to set the permission. If you want to be able to write into this file, you need to write here W. And in this case, all the content of the file will be erased and rewritten to what you will write later. If you want to just add new lines to a file, you write here A, which stands for append, and you will write the next lines in this file. So in my case, I will rewrite the file every time. So I opened this file, and f now is the variable that contains this file. And now f dot write will add some text to this file, and here I will write something. My first line. Okay, my first line. And then f dot close, a method that will close the file and save the file. So when you run that, it will create a file in your directory where the code is located. So I'll save this program and run it. Yes, now we have this report.txt, and it contains my first line. And if I run this program again, it will still contain the same line. All right. And what if I write A instead of W here? Play. I have report, and now I have my first line and my first line again. And this is all in one line. What if I don't want it to be in one line, but into a separate line? I need to break the line with the break line character, which is \n. And let me run it again. And now I have, wait a second, it didn't work. Yes, and now it added a new line into the file. I can run it several times, and there will be several lines. And they are being added because the A is as a second argument in open. If there will be R, W, then I will replace everything with one line. So this is one line. How do we implement this in our code? Let me edit my program. And I want to not only output to the terminal the height of the object, but also to save the data into the file. Let's first print the height. So print height. And now we want to add this line of the height of the object to the file. Let's before we fly, let's create a new file with f equals open report.txt and w. All right. Now, in this function, if we want to add to f, if we want to add something to f, we need to make it a global variable because otherwise it will not be saved. So global f. And now, after we print the height, we will also write str height. Why do we need to str here? Because it will change the type of this variable to string, and we can only write strings. So, and here we will also add \n. and it will create a new line for the next line. So the next write will be on the next line. Let's check how it works. Okay, seems to be fine now. Let's check. So the first distance was 0.59, and the next point (1.35), which is more than we expected. Oh, what is happening? The drone hit. (0.42), which is what we expect. It is yellow now. And the last. Zero. Okay. And one thing that we forgot to do is it will actually, this program will not write anything to a file because we forgot one thing, forgot to close the file. So in the end of the program, we should have closed this file. So f.close. And as we can see, the report is empty. Oh, well, it's not empty. It closed automatically when the program closed, well, which is fine. But anyway, if we wanted to close it correctly, we should write fclose, and in this point, it will save the file without waiting for the program to stop. Sometimes it is helpful because if the program crashes, it might not save. All right, anyway, the report is here, and it contains the heights of our objects as it measured them. And also, I think we should give the drone some time hovering over the objects because it is dropping the height and needs some time to maintain the normal height. So let's use ROSPY sleep, at least 1 second. And I will paste it before every check height. All right. Okay, now this is a this is a new topic. I want you to reproduce it in your own programs. So add this functionality so you can write and open and write and close the file. And then we will have a little break, after which we have a drone flight demonstration with some of the programs from you, and let's wait for that. So, which screen do you want me to keep on? I can keep the program. Okay, like that. Okay, and while you are working, we need to decide which program to run on Real Drone. So Svetlana, are you here?
Yeah, I'm here.
So which programs do we want to run on a real site on a test?
It's up to you. So I would like to suggest to make a short tour about our other drone laboratory and demonstrate the real Clover drone flight.
Mm-hmm.
We can make it in the break, after break time, for example.
Yeah, we will have a break shortly. After we have the first results from participants who are trying to open and write files. So after they do that, we will have a little break, and
okay, so it's no problem. But if now will be a practice time for our participants. So guys, if you will do it, right, it's okay in the Zoom chat. But if you have any problem with run the code on your machine, you can send your code to Lena or Nikita or Timofey, and they try to run your code on their machine.
And Yelena, okay, so that Ashutosh Agrahari sent me the code, and he said that he told you about.
Yeah. Team from India has a problem with Telegram connection for today, and they ask us to comment their code. So we can do it, for example, after our session, in the end of our session. Okay,
we can do that.
Yeah. Now it's the main program of our camp. And after it, we will check the homework. Timofey,
Yes.
how much time you give our students for practice of this task?
Well, it's no more than 10 minutes. It shouldn't take that long even. So
Okay.
whenever somebody shows the result, we will have a break, and after the break, we can demonstrate the new laboratory and the flight of the railroad.
Okay, great. So what the finish time in 25 minutes, I guess?
Yeah, in 25 minutes, and at 25 minutes, not in. And
Sorry.
and then we will have a break.
Okay, guys, who will be first to demonstrate the result of the first practice exercise? Then you will go to the break time soon, the sooner.
I would be ready.
All right, you can show us.
The measurements are a little off.
So show the measurements again. And you can run the program now. Yeah, this is correct. I see that the first is almost 0.5, the second is almost 0, and the third is almost 1, and the last one is almost 0.5. This is the right measurements. And yes, good job. Anybody else here who wants to show us? Or if nobody else, then we can have a break for 10 minutes.
So the break time was started or no?
Well, we can start the break here and write in the chat when we will continue.
Okay. Count down 10 minutes. I have prepared it in this time.
Hi, Timothy. I'll send you my codes in Telegram. Please go through it and please run it, okay?
So the time is over. Break time is over. Okay, Timofey, are you here? Anybody is here?
Yes.
Oh, yeah,
Yes.
perfect. um, I think we can continue in 1 minute. 1 minute. Oh yeah, Timofey is here. Perfect.
Hello. So should I show our new laboratory? Yes. Okay. Welcome back to us. And this is our new laboratory. It is located in Moscow, in the University of Moscow Polytechnical University. And here's our flight zone that contains Arco markers and different colored cubes that you can use either as cubes, or you can use each side of the cube as a colorful marker. There are some gates for FPV flight. Also, we have some computers for programming the drones and the drones themselves. And those are future participants of World Skills in drones, in aero robotics. They are preparing the drone for us. And this is a small FPV drone. We also have another room that contains all the other hardware that is available for us. But now we are going to check this drone and run our code on real drone. We need to make sure the laser rangefinder is working correctly, then we will be able to measure the heights of those objects. Okay? So wait a minute, I will connect to the drone and show you how it works.
Yeah, yesterday I have showed to you the workshop from Moscow Nuclear Power University, and at the MEFI, it was provided. It's a cost of inter-university competition, but in this workshop, we use for our different experiments of two, and of course that is why this workshop is free. We use this flight zone to demonstrate you how it's work in the real world, not only in simulation. And also, it will be interesting to know from your side tomorrow about your courses and activities in your country, in your maybe university or educational organization. We provide usually courses for drone assembling, piloting, and of course, autonomous flight. And also, we provide the project activities with the students from university. We, such as the COEX, can give them the order or technical or test project for develop any device for industrial drones too. Okay, Timofey, when you will be ready, you can.
Just a few minutes. I need to make sure that the drone measures its distance correctly, and when I've done, when I will complete this, I can run the code.
Oh, it's really great if you explain us how you provide the pre-flight check of the first autonomous flight on drone.
Yeah, I can do that. First, we need to connect to the Raspberry Pi, and when we are connected to the Wi-Fi, so this is the Wi-Fi network. Now we can connect via SSH, either from a client or from web browser, to the Clover. So this is the command line, the interface that is available for us, and some other programs are available for us that were on this drone before. And now I will add a new program here. I will copy this code, create a new program, nanohgt.py, and paste it. Okay, I've pasted it, and one little edit I should do, because the version of Clover firmware is a little bit different, so I need to change Clover to be Clever. Okay. And let me check the rangefinder. So ROS service call / rangefinder. Let me see. No, it probably is disabled in the settings, so I will change the settings.
Timofey, when you will be ready to run the quads or early, could you make a horizontal view from your camera? If it's possible.
Let me do that for now, yes.
Yeah.
So yeah, the rangefinder was disabled in settings here. So I've changed it to true in Clover.launch. And now I'll save it and use the command sudo systemctl restart Clover. After it restarts, the rangefinder will be connected, and I will check it again. Okay, now I can check ROS topic echo / rangefinder range. Okay. If it's not giving us the information, it may be connected not properly, but let me double check it before we fly. So This is the Clover drone itself. I need to check the wiring of this, the rangefinder. So in the article, we need to make sure the wires are connected correctly. VCC to this one, then, and then
Timothy, if you have some problem with the laser rangefinder, maybe we will check only flights, and after it we will check.
Yeah, we can do that, but I found out what was the issue here, and it was just a misconnected one wire. One pin was connected in the wrong position, and now if I restart, it should work. If it won't, we will just check the flight.
This time when each wire does matter, does it make sense?
Give it a second.
Yeah, this is the sound of the electronic speed controller. It reminds you that you forgot about your drone and you should to pay attention on the Clover drone and try to fly it.
Yes, and working with a simulated drone is much easier because you cannot connect wires in the wrong order in simulator. But in real drones, it happens sometimes. Topic. Okay, let me try that. In the best case scenario, it will return the height, but I think we just can fly with this drone by the program. So I have a controller here. I need to make sure the drone is flying manually. So let me fix somehow the phone and I'll make a flight myself. Yes, the drone is flying fine, and we can now test the program. Okay, let me show you how do I start the program. So in terminal, All right, Python, then hgt.py. Okay. You put the phone the way that you can see the flight. So the program worked, but it was only a red indication because the rangefinder still wasn't connected properly. If I would have if I would have prepared the drone myself, it would have been connected properly, but who knows? Okay, we can now proceed to our program. Svetlana, do you want anything else to say?
Thank you, Timofey, for demonstrating the real flight of the drone. And I would like to notice about the flight zone. Looks like the place for cats, playful.
Yeah, cat playground.
Yeah, playground. Yeah. Okay, I think we can continue work in the simulation. And
yes, I need some time to connect from my computer, and then I will be back.
Yeah. Thank you, Timofey. So also in the several workshop, we have not only educational equipment and industrial too, but for now we work with education because our students has a no so good level of experience of it, and that is why they try to work with educational equipment. But after it, maybe then we'll continue their work with the big industrial drones and the different stands for the check the equipment such as motors or battery or drone sensors. Okay, guys, maybe if you have a question about the workshop or maybe equipment, maybe courses, you can ask it now before Timofey preparing to the next steps. Yeah, I will show you the industrial drone. I have the photo of it. Just a moment. unfortunately, I didn't find the Pelican on my phone for now. But this is a Pelican with for monitoring, and this project was developed for research in and working in Arctic condition. So the main goal of this drone, it's monitoring of the ice items. And also the similar model will be developed with the Grab, and the Grab should work with the special sensors which drone should to deliver on the ice in Arctic and then come back on the ship. And people who work with this drone, they can give information and data about the movement of ice pieces. So about the question how drone show the height into the terminal and the real drone. So for educational drones, for example, drone can measure their height using the barometer. Or information from the Aruka markers field. And laser rangefinder uses only for not more than for 3 or 4 or 5 meters. But for big drones, we use the similar sensors, barometer, and sometimes GPS, but GPS can give us only coordinate in 2 coordinates. And yes, in this case, we use a barometer system.
Okay, Svetlana, I'm ready to continue now. And
okay. So and okay, yeah. Thank you, Timofey. Okay, you can continue. I have stopped my demonstration.
So our next topic for today is maybe for some of you it will be difficult. This is how to read QR code data from the drone. So you get the QR code on your Aruka marker field, on your world, and the drone can read this data and fly to the coordinates that are inside the QR code or do any other type of activities that is in the QR code. So first, let's create our first QR code with a website, the QR code generator. And this website is, in my opinion, is the easiest for you. So there are other sites you can use, and this one is my favorite. I can send you the link to this website. The internet doesn't load. It's because I changed my Wi-Fi connection during the virtual machine work, and I need to restart the virtual machine actually. Then it will have internet. So the easiest way to put QR codes on the field is to replace the texture of Haruka marker with the QR code. And this is why we are generating the image, and we will edit the model of Haruka marker field. So you can enter text here in this field. That could be text or numbers or anything else. That would be the numbers in this case. So I will create a QR code that contains a list of points for us to fly through. So the list of points will be like X, Y, X, Y, X, Y, X, Y. And first X and first Y is the first point, second X, second Y is the second point, and so on. So let me create a small list like 2, 4, 1, 1.5, 3.5, 6, 7, 3, and like 8, 5, and this is it. So we have first point would be with coordinates 2 and 4, 2x, 4y. The second point is 1 and 1.5, 1x, 1.5y. The next point is 3.5 and 6. The next is 7 and 3, and then 8 and 5. We can now generate the QR code. It is already here, and let me change the settings. So the resolution of this image is now 200 by 200 pixels. I will set it to 100. I don't really need to have high resolution here, and save as PNG. Hit save, and in the browser hit save again. So save file, and OK. It shows me the file. So this is the QR code. And let me replace an Haruka marker with this QR code. So let me show you how to do that. Open Home and type here .gazebo. Are you following my steps? If so, I can go a little bit slower. So if you go to Gazebo and Models, you will find Haruka Smith.txt, like the model of our Haruka marker field. And here we have materials folder, which contains textures and scripts. So those are some predefined markers that I used earlier, and I don't really use them now. I can put another one in this folder, QR code.png, but I will better change its name to the marker that we want to replace. For example, if I want to replace the marker with ID 91, I need to find this actual marker, marker 91. So if it is in the bottom of the list, hit right click, rename, and copy this name. And I also need to edit its own name to like underscore marker 291, and now it makes this file invisible for the Gazebo when it loads all the files. And I will replace it with this one after I rename it. So I rename it and paste the name of the marker that I want to replace. And I will now put this Haruka marker here. So this is the fastest and easiest way to put a QR code on the field. All right, we now can close this folder and this folder and open Gazebo to check if it's already there. All right, we have this QR code on the field. Look at this. And if you fly over this QR code, you can write a program that will read the information from this QR code. So let me open the Visual Studio Code and write this program where we can read this QR code. Did anybody else add a QR code to their field? If you want, I can send you the QR code that I'm using right now. Let me do that. Okay, so this is the QR code that I'm using. You can add it into your folder. And for now, let's go to clover.coextech programming and computer vision basics. Okay, here in this article, Computer Vision Basics, you will find useful information about working with computer vision, OpenCV, or the example of reading the QR code data. So this is the example I'm talking about. I will share with you the link. All right. And now let me show you the last script that is in this article. It says QR code recognition in Python. And this is the code. Before we test this code there's a very important step you need to do. If you read this last lines, it says that the script will take up to 100% of CPU capacity because it will read the QR code on each frame of the camera that is available. So if the camera has a frame rate of 30 or 40 Hertz, then it will try to find QR code in each and every frame from this camera. And it costs a lot of CPU power. And it will slow down your virtual machine or slow down your Raspberry Pi if you are using a real drone. If you subscribe to main camera image raw topic, this is why you need to create a new topic that is the same as main camera image raw, but has a slower frame rate. It is done by editing the main camera.launch file. You will add a node that will create for you a throttled topic. It means that this is the topic that has slower frame rate than the original main camera image raw. So before we do any other work with computer vision, make sure we create this new topic and that we will subscribe to this new topic with throttled frame rate. So I will copy this line here and go to my file system in the simulator, Katkin WSSRC Clover launch and find main camera.launch. In this file, I'll scroll down to this line. You see that there is a line 39, which is /node. After this line, I will create another node by pasting what I've just copied. So it is a node that is throttled, and it is closed with a slash in the end. So this is just an XML file. Basically, if you're familiar with XML language, you will understand what it does. If you're not, a short explanation is like this is a node tag. You open a node tag with this type of braces, and you close it with /node tag. But the other way to close the tag is to put the slash in the end of the tag. So node starts here and ends here. All right, I will save this and close. And now when I start Clover again, I will have another topic that is is called image raw throttled. Okay, and now I can copy this script that says that does the reading of QR codes. Let me copy this script. And I will create a new program for that. And paste the script. And you may notice that there is no flight in this script, so I need to add some code for being able to fly, to take off and land. And I will take this from my previous scripts, like 5.py, which has I'll better use not that one, but previously written 3.py because it doesn't have extra lines that make LED. Okay, I'm copying this from here. Raspberry math Clover. Copy. And let me see Raspberry. Okay, it's better to copy it by partially. So I will need to only copy this and the math. I will type math manually. So copy these ones and import math. Okay. Then ROS.NET Node is already in my program. I don't need to copy this again. And those are the services I need to copy as well. So copy them and put them right below the ROS.NET Node. Then I will copy my navigate wait function and put it on top of the dev image callback function. All right, and now I'm able to fly in my code, and I will copy the takeoff and navigate wait from here to be able to use it in my program. And I will not use ROS.PySpin, so delete ROS.PySpin. It's not necessary. You must delete it from here because otherwise the program will not continue, will not stop automatically. So you just remove ROS.PySpin from here. Okay, it is navigating up, and then I will need to navigate to the coordinates of x1. Hover there for some seconds, and I also need to change the height of the flight here because QR code can be read when you're close enough to that. So I need to set coordinates 1, 0, 1. Probably 1 meter will be enough, but if not, I can even decrease it to 0.8. Then ROS.Py sleep for maybe 3 seconds and then land. Save the program. And one more thing, very important. Remember, I've created this image raw throttled topic, but I haven't edited this default topic image raw here. So I need to change it to image raw throttled. And now it will work correctly. Do you have any questions for now? Okay, we have our QR code. And let's run the program that will read the QR code data. I'll run this program from another terminal because I want to have a smaller window on the left. And I will, I have no module called PyZBar. This is an issue on simulator because PyZBar is used for reading QR codes, but it's not pre-installed. So you need to install the PyZBar module by typing pip install PyZbar. Once it's installed, you can run this code again and it will work. All right, we can now test the code again. So I have a question. What does queue size do when we subscribe to a topic? Well, basically, when you are subscribing to a topic, it means that you have a set of messages, like a flow of new messages that appear in during some period, and you have a function that is executed on each new message. Sometimes this function takes more time to work. Then you have a pause between two sequential messages from your topic. By the way, this is the data of QR code. And if there is this kind of delay, there are several ways how to handle that. You can either stack the list of messages to be executed later, to have this code executed on them later. It means that you have a queue that will contain all the messages that haven't been executed but have already been sent to you. The other way is just skipping the messages and just waiting until the function stops working, and it will use the latest, the newest messages, and all the previous messages will not be executed in this subscriber. So in my example here, I have a function image callback that is sent as an argument to the subscriber, and queue size equals here 1. It means that there will be no queue. The new messages will not be accumulated and stored. So they will just, if the function is still busy, they will just go away, and the code will not be read on them. Once the function stops working, a newly added message will be executed with that function. So this is what queue size means. You can create a queue size of 10, and you will have a queue of 10, but I don't recommend you doing that, because you don't need to process each and every frame you get from camera. You need to process just some frames, and this is it. So queue size 1 is a good option for you. Okay, and now what does this function do? Let me explain you in more detail how it all works. And I've just demonstrated that it writes to the terminal this kind of data. Found QR code with data 2, 4, 1, 1.5, 3.5, and so on, with center at these coordinates. And we can remove all these prints and just have our data. Let me close the simulation. So this is the line that is being printed. So found btype with data bdata with center at XC, YC. So this is a formatted line of code. The first curly braces will be replaced with this, the data from this variable. The second set of curly braces will be replaced with the second argument here, and so on and so forth. But we don't really need to know where the sender of QR code is and what type of the QR code is. We only need data. So bit data is barcode data encode, which is the only thing we need. I will not go in too deep into details of how it works because we have limited time. But I just explain you that sometimes in the image there is more than one QR code, and this function will read all of the QR codes that are on the image. Yeah, and there is a question: is there any problem with reading single frame for QR reading? This is not a problem. You can do that, but sometimes the drone does not read the QR code from the first attempt. This is why it's better to have some sort of a loop that reads through several images unless it finds something. This is why we use this subscriber here. In real life, QR codes may be hard to read. Even in simulator, they're not being read every time. For example, if we have a height of 2 meters, you will never read this type of QR codes because it's too high. Okay, basically, let's simplify this code a little bit and remove bit type, all these lines from here. We'll remove them because we don't need them. Another question I get is how to display QR debug. What exactly do you want to display? We can we can display data from QR coding terminal, or we can create our own image topic, but this is not in our course for the moment. Yeah, you can display that, but we don't have this in our schedule, unfortunately. So you can read in our data, in our knowledge base, how to post a new topic. Okay, so I will continue. And now, instead of printing the QR code, I will put it into a new variable, the same way we did for distance. Remember that? I will create a variable called countQR, and the value of that would be empty string. And here, instead of print, I will create a small change. Not bdata equals barcode data, but QR equals barcode data. And to be able to change a global variable QR, you need to set it as global. So we write global QR here in our function. And now this function will change the value of QR for the entire program, and you will have the updated version of this code. Okay, now what we can do with that information? We need to change its type, because by default it's a string, and we have list of coordinates in this QR. How do we extract list of coordinates from there? Well, let's do it in here. First, we have this ROSPY slip, after which we want to process the data from QR code. We can, instead of ROSPY slip, we can create a while loop that waits for the QR to be read. It is a better way of doing that. So while QR equals empty string, cross pi sleep 0.2. Okay, and it will check it 5 times per second. And when you get some data, the loop will be broken, so we will break out of this loop and continue working with the QR code. Okay, so you need to create a new variable, QR data, for example, and this variable will equal to QR.split. What it does is, if you have a set of digits like that, and so on, after executing the split method on that line, it will give you a list of.
Hi, Timothy. I think
Yes.
in line 48 you have missed. That is QR, not RQ.
Oh, which line?
48. 48.
Oh, thank you. You are. Yes, this is much better. Thanks a lot. And okay, what will split do for us? It will change this line of text into this type of variable that contains all the single character. I mean, not character, but a word that is separated with space. So if there is space, it means it's a separator, and you will have this new list of all these values. And this is already better for us because we want to be able to address to each one of these values. Okay, what do we do next? QR data equals QR split, and this is this type of list, but they are all strings. So this is a small string, then a small string, then a small string. What do we do with that? We could actually change the type of this string whenever we use them, like navigate and the first element of this list, and we turn it into into a number. But it's better to execute a map function on each element of the list. So what do we do next? QR data equals map, and here we need to choose which function we are going to apply to each element. In our case, it's float because we want to turn them into float, and then we write QR data here because this is the list that we want to execute on. So now our QR data will be turned into this type of list. Of course, the numbers will be different depending on what's in QR code, but anyway, this is the right type we want to have. And now we can fly through each of the points that are given to us. So let me see. For example, if I want to first visit the point 2 and 34, well, 34 is not existing in our field, but let's pretend it is there. So I want to navigate weight to the coordinates QR data, squared braces, zeros index, comma, QR data, braces, and 1 index. So this is our first navigate. It will get us to these coordinates. The second navigate should start with 2, like 2 and 3. So let's use another navigate weight. QR data 2, QR data 3. But this is a manual work, it requires some time, and moreover, if I don't know how many elements are in this list, the program will be broken if I try to access the value that is not inside. If I try to access the index that is out of the range of QR data, what do we do here? The solution for that is to use a loop another time. So how to use it in a loop? Okay, let's do that with a for loop this time. For. Why do we use for? Because we want to actually run through each element of the code. So we can have a for I in range, and the range should be the number of tries, the number of repetitions in this loop. We can get this number, but by actually length of the QR data list. So we use len QR data. Okay, so for I in range len QR data, and but the data contains x, y, x, y, x, y, x, y. So the length of QR data is twice as long as the number of points we need to visit. So we need to have this len QR data over 2. Return us the number of repetitions for this for loop. And here we can use navigate, but in QR data 0 we will write QR data I, and QR data 1 will replace it with the I plus 1. This is not necessary anymore. Now this code will run through the list of these points. No matter how many of them are in this QR code, and I don't need these lines, of course. I will remove them. For now, I can comment them. And when we are finished, we can go to the 0 point and land. Okay. I will change the speed to 1.5 because it is kind of slow. And now we can start this program. Oh, by the way, I want also to print the data from QR codes. So after this first loop, I will print QR. Okay, this is it now, and let's start. So the drone should fly over this QR code and run through all the other lines, all the other points. Let's run. Let's wait for the QR code to be read. Yes, it printed the data and now it's going to the 2 and 4. 2 meters and 4 meters. Then to 1 and 1.5, which is here. Where is it going? Is there a mistake? Yeah, I think there is a mistake in my code. Sorry for that. I know what the mistake is. Can anybody tell me where I was wrong? So it should have gone to the 1 and 1.5, but instead it went to 4 and 1. So
because of 4, it only iterates plus 1, 2.
Yes.
Yeah.
So we can say that the I equals, no, I yes, that will make it double the size of iterations. So it now will iterate from 0, then 2, then 4, and so on. So what is this thing? It means that E equals E times 2. It's a shorthand for that. Let me run the code again. Let's see what it does now. Why is it still going? I forgot to save the change. Yes, my bad. I forgot to save the change. Let's run it the final time. I hope it is the final time. And this will be the final thing in our today's lessons. So let me see what it does now. Seems like it's fixed the problem. And now it is going to the correct coordinates, which is 1 and 1.5. Yes, the program is working. And in the end, it will just go to the original starting position and land. Okay, guys, on this topic. Did you reproduce what I'm doing here? Well, this is a part of your homework, so you need to reproduce this for passing the homework. And Svetlana, where are you? You can tell us more about the homework.
Yeah, I'm here. So, and I hope you are ready to get the third homework. So, Timofey, we will explain homework now or later?
Yeah, we can do it now.
Okay, perfect. So,
Svetlana, should I load the world for homework?
Yeah, sure.
Well, I can show how to load it if it's needed.
Okay.
Yeah. So have a new world for this homework, and I will show you how to load it and what to do next. Okay. Share my screen again. Okay, you will all have this QR homework zip folder. You need to unzip it, and inside this QR homework you have models, which contains only from Argosmith.txt and Clover World and simulator.launch. First, let's add this model. No, I need to go to Gazebo models. And I will replace the default Argo.txt with the one else. Okay. And those files, Katkin, src, Clover, Clover simulation, resources worlds, and put the clover tree.world here. Then go back to directories and go to launch and replace simulator launch with the 1. All right. And this is going to allow you to work with a new world. Okay, this is the new world, and it has multiple QR codes, and the one QR code in the beginning. So this is the code that contains information about all the other codes. So there are coordinates of other QR codes, and other QR codes. You don't know their coordinates, and you must read the coordinates from this code, fly through each other code and read its data. And what do you do with this data? Svetlana will explain you right now. So Svetlana, share your screen and explain the task.
Timofey makes some surprise for you. Just a moment, I will share my screen. Yeah. So this is your homework for tomorrow. And Timofey has demonstrated the Gazebo world for you and how to install it. So what you should to do? You should to make takeoff and fly to the first QR code like this one and read it. All information which you have read it, you should to fly to other QR code, and because you can give the coordinate of each QR code in this in the first QR code. So, and next you will fly to each QR code, read the data from this QR code, and depends on the data. It can be free or busy. You should to choose the LED strip, green for free and red for busy. Please post all information from QR code into terminal. And next, you should to write the data to the TXT file and calculate the number of the free or busy points slots. And also the main thing of it, don't cheat it, because when we check your homework, we can change the QR code's data. For example, this QR code consists of free, but we can change for busy. And the total number of the free and busy points will be changed, and your code will be should to work correctly. Timofey, would you like to add something?
Yes, I would like to add something.
Yeah.
The number of points will also maybe different. So this is why please use the for loop for to go through all of these points. and don't go manually by navigate and so on and so on. Just create a for loop, which is not difficult at all. And this code, your code, that way will work on any type of combinations that we will provide. This is what I want to tell you about that.
Okay, guys, this time for your questions about the homework. Are you happy to perform it? Silence, it's mean yes. I guess.
Yeah, it's okay. There's no doubt.
Okay, so if you don't any questions about your homework, about your next homework, I think maybe our teachers Elena and Nikita would like to add something, information about their homework, about this homework or about your previous homework. Nikita, Lena.
Yeah, the results of homework last already sorry ready, and we will send you them to you.
Oh, perfect. So guys, you will see results of your first homework. It's maybe second homework because it was the second day of the camp. Okay, we will post this information in our chat. So, and finally, I would like to remind you about our tomorrow meeting. So tomorrow we have a plan to provide the summing up of our camp. And tomorrow, don't forget to prepare the short presentation or video, or maybe short story about your organization, about you, about interesting drone activities, and maybe project in the drone area from your side. And it will be interesting for all. And also don't forget to fill the reflection form. And also tomorrow we will tell you about different and many type of the competition when you can take a part in the future on this year, and any and other activities that can be interesting for you. So maybe anyone wants to add something useful information. And before you preparing your important information, I would like to ask you turn on your cameras, because this is a time for finishing. But if you have questions or anything, you can ask us or tell us. For now, this is the best time for it to do it. So guys, I see that you don't tired. So it was very interesting information from Timofey, and Timofey make for you very hard work, but you don't tire it. What happened? How it can be? Okay, so are you ready? I hope you are ready to take a common photo. So I see many of you turn on your cameras, and it is great. And I see the smile on your face. And I have a interesting accessories to take the best photo. I think you can know about it. So guys, are you ready to take a photo? This cat can be on the hand or the hugs only 3 seconds. So 3, 2, 1, just smile. Woo! Hola. Help me. Oh, yes, it was one time when the cats take a photo, but okay, so to try again to take a best photo. 3, 2, 1, smile. Hey, perfect. Just a moment, and let's try again. Sorry guys, just a moment. The cats the cats perform amazing things, but unfortunately you cannot view it. Okay, so take a photo again. Last chance to get the best photo. Are you ready? Steady. 3, 2, 1, smile. Yay, perfect. Okay, it's I think it was the best photo.
I'm sorry, I have to leave. I just got a call from someone. I don't know. So bye, I guess. Sorry.
Bye.
Take a photo again.
No, all good. Thank
Okay,
you.
okay.
Bye.
Okay, thank you all guys, and thank you for your hard work, and thanks to our trainers, Timofey. Timofey is a really best trainer who have prepared some very interesting material and useful for you. And many thanks to Lena and Nikita to support you, and they will await your homework today and tomorrow and ask all questions. And have a good mood. See you tomorrow at 3 o'clock. Yeah. Bye. You can unmute your microphone and say bye. Hey, bye.
Bye. See you tomorrow.
Goodbye.
Bye. See you tomorrow.
Ciao.
Bye. Ciao. Buenas tardes. Noches. Buenas noches. Yeah. For Russia, it's evening for now.
Boa noite.
Okay, bye.